the last type of variation is joint variation, and that just means you're going to end up having three variables. So z varies directly with x, and z also varies directly with y. Now you always have to pay attention to which one it says first. So on all of the inverse and direct variation, it always talked about y varies directly with x, or y inversely varies with x. So whichever letter it talks about saying varies directly, that's what needs to go first in this equation that I'm about to show you. So z varies directly with the product of x and y. Now we really haven't talked about using three variables. We will get to that as we get closer to the end of the year. But for x, y, and z, it's just three variables. So if you look, the equation is z equals. So since we're talking about z varies directly with x, then z equals k times x times y. Remember, k is just the constant. Okay, then we have, so this is our table that we're going to look at. So notice the base, the height, and the area. What this is coming from is if I have a little tiny picture like on my phone, and then it gets scaled up and going to be printed on a big 4x7, this base has to scale up to this base, and the height has to scale up to this height. So those are going to vary directly. And then the area is also the same, because if this was 1 and 1, 1 times 1 is 1, so the area would be 1. If this was 2 and this was 2, 2 times 2, so the area would not be 2, but they are all moving up together. So they're all moving up by a factor of 2. Sorry, I said that wrong. But they're all changing by a factor of 2. So I'm going to double the base, I'm going to double the height, I'm going to double the area. So that's what it's talking about. So notice they all move together. Okay. The constant of variation on this, constant of variation. So since I gave you the equation, z equals kxy, I'm trying to find the k, or get k by itself. So notice I need to divide by x and y. X and y. So then your constant is equal to z divided by xy. You will also see constant of variation written as constant of proportion. Sorry, I'm making sure I spell it right. Proportionality. Oopsie, and I still spelled it wrong. So the constant is equal to z divided by xy. So whatever letter is here, you're going to divide it by the other two letters. That's important because the main reason we usually talk about joint variation is like when on your assignment you're going to talk about interest and principal and the time that you have alone. So that's why you always have to make sure whatever it talks about the others vary directly with this one, you want that letter to be on top, divided by the other two. So like if it says the interest is directly proportional or varies directly with the principal and the time, then it would be interest on top. Okay, so let's go ahead and do one of the examples. So if I told you to find the constant when z varies directly with x and y, when z equals 15, x equals 1, and y equals 3. So we want to plug these numbers into this equation. So it would be 15. So since it says z varies directly, 15 is on top, divided by 1 times 3. So 15 times 1 times 3, or 15 divided by 1 times 3, well 1 times 3 is 3. 15 divided by 3 is 5. So 5 is our constant. Now, if I told you to find, for that same problem, find y when x equals 4 and z equals 40. So you can plug in this information you know either into this equation, into this equation or this equation. We already found our constant, so we know our k value is 5. So I'm going to just go ahead and set it up with the z equals. So z equals kxy, and plug in what I know. So I know z equals 40, so it would be 40 equals, our constant is 5, times x, which is 4, times y. So 5 times 4 is 20, so 20y equals 40. Solve for y, so divide by 20 and divide by 20. So 40 divided by 20 is 2 equals y. So your y would be 2 in this case. Okay. So joint variation is just like, or is a lot like direct variation, or inverse, just depending on which letter you're talking about. But it just means, joint variation means there are three variables varying directly with each other.